Okay, so consider a box sitting on a plane like this. And let's assume that this plane is level and strong enough to hold up this box. The forces acting on this box would be, well, gravity would be down, right? And that force would be roughly 200 newtons down. The surface would exert a force on the box, right, of an equal force, right, to hold it up. So let's assume the plane doesn't break. These guys would be equal and opposite, and generally nothing happens up and down, assuming the plane is strong enough, right? I'll just ignore those. But if you're designing a bridge, obviously you can't ignore this. You need to make the bridge strong enough to exert a sufficient upward force to keep the car from going through the bridge. Okay? Now, the 17 newtons of friction force, there are two types of friction, and we'll talk about that later. Let's assume that that's the kinetic friction, the friction that exists when the box is moving. Okay? So if the box slides to the right, if we're dragging the box to the right, there's going to be this 17 Newton force acting this way, right? So we might make that negative 17 newtons, right? And then if we exert some bigger force this way, right, it might accelerate actually in this direction, okay? So what we're going to do is, the whole gist of this is we're going to use F equals ma, right? This force right there is actually the sum of this force and this force in the horizontal direction. This has to be the vector sum of all the forces, okay? So that's the key here, is that this isn't this force or this force. It's the sum of all the forces equals mass times acceleration. And sometimes the acceleration, we have to solve a kinematics problem to do that. So let me just give you an example where we don't know the acceleration, but we know the forces, okay? So the box is sliding to the right. Okay, and I exert a force of 78 newtons to the right. So let's draw this. And I'm going to ignore those up and down forces. Let's just assume that gravity's pulling down and the surface is obligingly pushing up, right? I'm going to make this be 78 newtons. I'm going to make the positive direction be to the right. So that's positive 78 newtons. If the box is sliding to the right, then this friction force is going to be 17 newtons to the left and therefore negative. Okay? So there's negative 17 newtons. And then this is easy. We can just set this up, right? I'm going to say F equals ma. F isn't just one of the forces. It's not this one or this one. It's the vector sum. So I go positive 78 minus 17 equals 20 times a. And we don't know a. All right, well, this is not so hard, is it? So 78 minus 17 is 61. And then divide by 20. And we get 3.05. Positive. So that means it's going to accelerate to the right at 3.05 meters per second squared. Now the only moral dilemma here is, do you round that up or down?